Good morning, students. Today we will discuss about the nodal analysis. So, here there are a few steps to uh, proceed for the finding the node voltages for the given circuit diagram. So, here for every given circuit, you have to identify the reference and non-reference nodes. So, this is the first step. So here after identifying the reference and non-reference nodes, so we have to assign voltages for the reference nodes and non-reference nodes. Here always we will assign 0 volts for the reference nodes, and only one reference node is present for a given circuit diagram, and for the remaining non-reference nodes we will assign like this: v1, v2, v3 up to so on, up to vn minus 1, where n is the number of nodes in the given circuit. So after assigning this, we will apply the KCL for each of the n minus 1 non-reference nodes. Only we have to apply KCL for the non-reference nodes only. Next, after applying this, we got the equations for these non-reference nodes. How many number of non-reference nodes are there? Such number of equations we obtain. So solving the resulting equations to obtain the unknown node voltages is the final step of the nodal analysis. Okay, so now we will also we have different types of numerical problems in this nodal analysis concept. So the circuits only with independent current source. So how to proceed in this when only independent current sources are present? Like this, when both independent and dependent current sources are there, so how to proceed? This is the second method. And in the third method, we have voltage sources. So here the voltage sources is located between a non-reference node and a reference node. This is third method. What happened when the same independent voltage sources is located in between two non-reference nodes? That is a super node concept. We will discuss now. Okay. So coming to this here for the first classification, first numerical problem here. So this is the circuit diagram they given. What they are asking: obtain the node voltages in the circuit shown in the figure below. So this is the circuit diagram they given. In this circuit diagram, you observe totally 5 elements are there. Okay. So among them, 3 are passive elements, 2 are independent current sources. Okay. So here how to proceed? Here what is the first step we have to go for? Here first step is identify the nodes. So what is a node actually? Node means it is a point or a junction where two or more branches are interconnected. So first of all, identify the nodes. After then we will go for the reference and non-reference nodes. So which is the node here? So here observe there where the two or more junctions are commonly connected. So you observe here 1 ampere and this 2 ohms and this 6 are commonly connected at this point. There is no other element in between these three elements. So that's why these three elements are commonly connected at this point. Okay, so this is a one node. The next one here, six, like this 4 amperes is also commonly connected here. So that's why this is also I will consider it as a node. Okay, next one, all these 1 ampere current source, 2 ohms, 7 ohms and 4 amperes are commonly connected here. Okay, so these are commonly connected. There is no element here. Okay, so that's why I will consider this a common node. Now observe here, this node is commonly connected to the most of the elements. So that's why I will consider this as a reference node. This is a reference node. So here, what is the voltage? Here I am assigning 0 volts. 0 volts is the voltage I will consider for this reference node. Next, the remaining nodes. This is here I consider this as a node 1. So at this node 1, the voltage I assign here, it is a V1 is the voltage. V1 is the voltage. At this V2 is the voltage. V2 is the voltage. This is the second node. So now we are going to find out what is the V1 voltage value and V2 voltage value. Okay. So by obtaining these node voltages, we can easily get what is the current passing through each and every element: 6 ohms, 2 ohms, 7 ohms. Clear? So no. First of all, apply KCL, Kirchhoff's current law, at node 1. Okay, at node 1. So how to do this? So at this node 1, so what are the branches are connected? First of all, identify them. Here 1 ampere current source and 2 ohms, 6 ohms, only these three elements are connected. So we have to write the KCL at this node. So what is the KCL? Algebraic sum of the currents at this node is 0. So that's why, what is the current here in this branch is a 1 ampere. Now you observe here whether 1 ampere is direction, the current source direction is entering into the node or leaving the node. Okay, we will assume the current which is entering into the node, I will consider it as a negative value. The current which is leaving from the node, I will consider it as a positive value. So here the current 1 ampere is entering into the node, so that's why I will consider this as a minus 1. Understood? So 1 ampere is entering into the node, so that's why I am considered as a negative polarity. Next, here 2 ohms is there. This 2 ohm resistor has two ends. One end is connected to the potential V1, another end is connected to the reference node 0 volts. So that's why, what is the current formula? Current formula is equal to potential difference divided by the resistance. So that's why, what is the potential difference? V1 minus 0. That is, current is leaving from this node. So that's why I will consider it as a positive polarity. Now V1 minus 0, that is the potential difference. V1 minus 0 divided by, what is the resistance in this path? 2 ohms. 2. Next, what about the 6? 6 is also connected to this node, same node. The 6 ohm resistor has two ends. The two ends are connected. One end is connected to V1 potential, another end is connected to the V2 potential. So that's why, what is the potential difference? V1 minus V2 divided by 6, which is equal to 0. So that's why here V1 has, I consider V1 has a higher potential. So that's why current is leaving from this node. So that's why I will take it as a positive polarity. Now I will I will solve this equation, simplify this equation. So here the LCM is 6. So that's why here 6, this is minus 6, and here it is V1 minus 0 is V1. So 3 into V1. The next one, here it is V1 minus V2, okay, which is equal to 0. So that's why, now what happened here, minus 6 plus 3V1 plus V1 minus V2 is equal to 0. Now 6 cross multiply, so that's why it becomes 0. So now here it is 3V1 plus V1, 4V1. Next, minus V2, which is equal to minus 6 here plus 6. So that's why this is the equation number 1. So this is how we can obtain applying KCL at the node 1. Similarly, apply KCL at node 2. So what happened at this node 2? Again, here you have to identify what are the branches connected here. Here at this node to 6 ohm resistor is there, and 7 ohm resistor is there, and this 4 amperes current source is there. Clear? So that's why what is the current in this 6 ohm resistor now. So here again in the same manner, 6 ohm resistor has two ends. One end is connected to V1 potential, another end is connected to the V2 potential. So what is the potential difference here? V2 minus V1 divided by 6. So that's why here the current is leaving, so that's why you consider it as a positive polarity. And next one, V2 7 ohm resistor is connected between V2 and 0 potential, so that's why what is the potential difference? Plus V2 minus 0, V2 minus 0 divided by 7, and this current is leaving here, so that's why leaving current is a positive I am considering, so that's why it is a plus 4. Okay, observe this one. Here it is, the current is entering into the node while writing the KCL at this node. So that's why I consider it as a negative value. Here the current is leaving, so that's why it is a positive value, which is equal to 0. Now take the LCM. LCM is 42. So now here it is 7 into V2 minus V1 plus V2 minus 0 is V2, and this is 6 V2 plus 142 into 4, 168, which is equal to 0. Now after simplifying this, 7 into V2 minus V1 plus 6V2 plus 168 equal to 0. So now we got minus 7V1. Okay, 7V2 plus 6V2 is 13V2, which is equal to minus 168. So this is the equation obtained from the second node. So that's why this is the second equation. So now simplifying these two equations, we got V1 equal to minus 2 volts, and V2 is equal to minus 14 volts. Clear? Okay, this is about this problem. Obtain the node voltages. So that's why V1 value and V2 value is obtained like this. Okay, in the next video we will discuss about the another problem related to when both the independent and dependent current sources given, how to proceed. Okay, thank you.